But anyway, he spoke of services, and I spoke of services earlier, and how that was a focus 8 years ago. Microservices is what it's evolved to. That was a profound concept years ago. The microservices and containers is where it's at today. So our next speaker, Jason McGee, is going to tell you all about that. Jason? Clap.
Thank you.
Good luck, my friend.
Appreciate it. All right, good morning. So I'm going to take you guys on a journey for the next half an hour about microservices. How many people in the room have heard the term microservices? Exactly. There's a lot of hype about microservices. Lots of people are talking about it. Lots of people are trying to understand what microservices are about, how it applies to how you do development and build your applications and how you run systems. I will tell you, microservices isn't just hype. People are really using microservices. It is absolutely, in its fullness, kind of a nascent or emerging approach, but something that has come out of the evolution of application development, some of the things that Max talked about, and also the evolution of cloud. And so what I want to do is kind of take us through what is microservices, what problem is it solving, and then dive a little bit into what are some of the attributes and capabilities that you need to be successful with a microservice application. So let's start with the motivation. Why in the heck are we talking about microservices? Why are all those people searching for it? And why do we even care? And I think, as always, it comes down to the pressures that we're all under within the context of our own individual businesses that we're part of. You know, we're all under pressure to deliver rapidly, to differentiate our capabilities. I think more than ever before, software and technology is the defining differentiation in many industries and businesses. So maybe 15 or 20 years ago, we viewed IT systems as a necessary evil to run the actual business. Today, we're actually using software to change our business models, to innovate, to differentiate, to survive against some competitor. And to do that requires us to find ways to continually deliver for real, not to prototype, but to actually build capability, to test that with people, and to put it in the hands of our users. To get to that rapid delivery, many of us have decided to leverage cloud, in a lot of cases, specifically public cloud, as a vehicle to provide the flexibility that we need to deliver rapidly, to get quick access to capability, whether that's core infrastructure or whether that's higher level things up the application stack. Public cloud is an enabler for that speed of delivery. We also have a need to be able to simply and rapidly scale, because if you're going to deliver quickly, you're frankly going to take some guesses and some risks. You're going to try some things. You're going to build a new application, a new mobile system, a new AI service. You're going to build something. You're not going to necessarily be sure which ones are going to be successful and which ones aren't. You want to be able to quickly experiment. But when something hits, it can go from nobody knew about it to incredibly popular in a really short window of time, and you need a system that lets you rapidly scale that application to meet those demands. So these are the problems we're trying to solve. The traditional approaches to building applications struggle to help us meet those challenges, right? And, you know, kind of traditional monolithic waterfall application structures, having a team of 1,000 people all work together on a common code base and build an application, doesn't work well in that model. All the changes are coupled. I need to change one part of an app. It causes a redeployment of another part of an app. It's hard to rapidly innovate in those architectures. A lot of those traditional architectures aren't designed for public cloud. They don't scale out, they scale up. They assume a level of infrastructure reliability that frankly doesn't exist in public cloud. Public cloud, you kind of have to design at all layers of the application for failure in the components you depend on. And scaling in those traditional architectures is hard because you have to scale the whole thing as a unit. And you need to apply a lot of resource, and sometimes the state management systems aren't really well designed for kind of a scale out or horizontal model. So a new approach was needed to help people achieve the rapid pace of delivery that we want in the context of the technology that we're using in cloud. And that's why I think microservices has started to gain a lot of traction, and why you see some of the more leading edge companies and born on the web properties leverage this approach at scale to deliver their solutions. So this is my definition of what a microservice is. It's an engineering approach. It's not a technology. It's an approach to building applications that focuses on decomposing the application into single function modules that have well-defined interfaces, which are independently deployed and operated by a small team that own the entire life cycle of that component, right? There's a lot of important attributes there, right? Decomposition is probably the most obvious. Microservices is about breaking things down into smaller pieces. I think the really important part is the idea of independent lifecycle, that each of those pieces can be evolved and deployed and updated and scaled and changed independent of everything else that's going on within that microservice. And maybe the less obvious thing is that really microservices is about people. It's about teams. It's not about technology. It's not about containers. It's not about API management. Those are all tools that we're using to achieve something about how our teams work. Right? Microservices is about how you organize a team of people to help them accelerate delivery by minimizing communication and coordination between people and reducing the scope of risk. Microservices is so that team doesn't have to talk to everybody else so much. Right? Let's not underestimate the time involved in coordination amongst 1,000 people. If you can isolate a group of 10 or 20 people to build a service and they have a well-defined interface, API boundary, then that team can operate and make decisions and make changes without having to talk to everybody on the planet every time they want to make a change, and that lets them go faster. So ultimately, it's about people. Now, I like to use an analogy when I talk about microservices to help people understand really what's going on. So here's the analogy, and you can tell me later if you think this helps you understand the concepts. How many of you have ever gone into a restaurant with a group of friends and had just an amazing meal? That ever happened to you? This is New York. There's like really good restaurants here. So it's really sad if it hasn't happened to you. When you go into a restaurant and you have this amazing meal with a group of friends, that's an experience that you're having, right? It's not a certain dish that you're eating. It's not one thing. It's the whole experience of the environment that you're in, the food that you're eating, how it's delivered, the wine and the drinks that you're having. You are having an experience. And that experience is delivered to you by a whole group of people. So if you went behind the scenes and you looked at that experience, right, think of that experience like an application that you're using, right? It has a bunch of components that have to come together. So behind that meal, that experience that you're having, there's a kitchen. And in that kitchen, there's this flurry of activity. There's all kinds of people. Some people are making main courses. Some people are making desserts. Some people are responsible for the wine. There's all of this flurry of activity that's trying to come together to give you that overall end-to-end experience as a user of that restaurant. And if you look deeply at the organizational structure of that kitchen, it is not a random chaos of people trying to figure out how to fill orders, right? It's actually broken down into stations. And each station is manned by a team of people who are responsible for one part of the experience. There's a pastries team that's responsible for desserts. There's a team that's doing the grill. There's a team that's washing dishes. And there's a team that's prepping food. And each of those stations and those teams work pretty much independently of each other. They have tickets that come into them, their interface. Those tickets say what they're supposed to produce. The people on those teams have skills that are unique to the job that they're doing. And they use tools that are unique to the job that they're doing, right? The pastry chef's tools are very different than the guy who's making main courses. They use different tools. They have different skills. They're optimized for the part of the problem that they're solving, and it all has to come together in experience for the end user. That's really what we're trying to do with microservices, is we're trying to figure out how to take this big problem, this experience we're trying to deliver, break it down into stations or small teams that are responsible for pieces of that experience, man those small teams with the skills they need for the problem that they're solving, and let them use the tools that they want to optimize that problem. Maybe It shouldn't all be in Java, or it shouldn't all be in one language. There's different tools that are better at different parts of the problem, and microservices enables that model, enables that organizational system to take effect where we can break down the problem, and each of those teams can go as fast as they need to and make the decisions that they need to be successful. That's the idea, I think, behind microservices. So let's look at a specific example. I'm going to describe a fictitious application, and we'll use it to kind of break down what a microservices app might look like, and then some of the tools that are available to help us solve the problem. So I have this application called Weekend Getaway. And the idea behind Weekend Getaway is this is an application built by a traditional travel agency, a company that does travel booking. And their historical business was pretty much straightforward, flight, hotel, car reservation bookings for people. And they're struggling to compete in a world with Kayak and Expedia and aggregated travel experience or travel booking websites. And so they decided they needed to build a new experience for their users. So they're going to build an app called Weekend Getaway. And the idea behind Weekend Getaway is to make it easy for somebody to book a quick last-minute getaway with friends or family. And what they want you to be able to do is say, hey, when do you want to go? Who's going? Like, how many people are going to go? How much do you want to spend? And what mood are you in? Right? You're interested in a beach experience, or you want to do some sports adventure in the mountains, like give me some idea of what mood you're in. And based on that information, and based on crawling your social profile and looking at data about what other people are doing, it's going to come back to you with a set of recommendations about travel packages that you might find interesting. You can select one, dive into it, and book it. So in the back end, they're still doing travel booking, but they're trying to build this completely new experience for how you do it. So what would an app like that look like, right? There's many ways that you could build this, but just for illustrative purposes, you can say if you broke down the collection of microservices that might go into building an application like this, you might get something that looks a little bit like what's on the screen. There's a set of services around the users, around a profile for a given user of the application. There's a set of personalization microservices that are responsible for doing things like reaching out to Facebook and Twitter and crawling your social profile and applying AI to it to learn about your personality and your likes and dislikes so they can do a better job of recommending packages. There's a service called the concierge, which is responsible for kind of putting the whole package together. For the concierge service to do its job, it needs access to a set of deals with the providers of the travel components, like the airlines and the hotels and tour groups and stuff. There's a way for them to plug deals into the system. There's a pricing service, which is responsible for going and figuring out the price of the whole package. And then, of course, there's an itinerary and booking service that's responsible for actually taking the package and making it real by interacting with their back-end booking systems to actually book the trip. And so you'd have this collection of services. They all have different roles, right? You could put a team on each of these services. Those teams might use different tools and technologies to accomplish their thing. Like in this example, the existing booking system was a Java-based transactional system. The team responsible for the booking microservice is therefore populated with a bunch of people who understand Java as a language, and they might choose that as the way they're going to build the booking microservice because that's the technology they're comfortable with. Whereas the guys doing the UI are a bunch of JavaScript programmers, and so using something like Node.js as the language is more comfortable for them. They can all choose the pieces and the tools that they want to build out these services. Now, what are some of the things that kind of cut across all these services that you need to be successful with microservices? To take this organizational construct we described for how people work and support it with tools and technology that enables that team to do their job. And I think the first thing you have to solve is how do I actually build and host each of the microservices? How do I actually construct them? And the reality is you can construct them in many ways. You can construct them in containers. You can construct them as an app in Cloud Foundry. You could construct them with a serverless system. You could put them in a VM. There's lots of technologies that can be used to construct the actual microservice itself. I think that containers and the container space is the dominant way for people to do this now and over the next 10 years. And when I say containers, there's lots of ways to do containers. The stuff that Max just talked about is a specialization of containers in Cloud Foundry. Serverless systems underneath are all containers. I think containers are the dominant system for building these going forward. They're not the only one. There are big examples, like what do you think is the most commonly referenced company doing microservices? Anyone want to guess? Netflix, somebody said it, Netflix. They're like the poster child for microservice architecture. They're doing a lot of stuff with containers now, but their original architecture for Netflix microservices is all VM-based, right? So you can do it a lot of ways. I'm gonna dive into one of them, which is containers. A lot of people are using containers to build services because it has a better DevOps cycle, it has better isolation, higher efficiency, you can go more quickly with containers, you have flexibility with them. And everybody's journey using containers starts in the same place, building my first container, right? And you build a container-based app, you package it up in a container image, you run it, it's cool, you love this container thing, it's really easy to use. You create some more containers, you create more instances of your containers, you create more microservices, those go on more containers, and before you know it, the world's a little bit out of control because you have like containers everywhere and all these container images and you don't have any good way to manage them. And so I think one of the first tools that becomes incredibly important in a microservice architecture based on containers is tools to help you orchestrate and manage the execution of all these container-based applications. And one of the dominant systems today for doing that is Kubernetes. And I think Kubernetes is emerging as kind of the de facto platform for building container-based applications. Its job in life is to bring control over the chaos of running lots and lots of containers. And one of the things that we've been doing in IBM with Bluemix, which Dr. Max talked a lot about, is bringing Kubernetes-based container orchestration into the platform as one of the runtime options for how you can build apps, including microservice apps. And the heart of Kubernetes is a set of capabilities which are really designed for taking kind of all the common concerns of execution of a microservice app and automating them for you. And you can look at Kubernetes in lots of ways. It does many things. But this is my summary of kind of the 6 key capabilities that the Kubernetes orchestration system brings to applications, right? First is intelligent scheduling. If you're gonna run this microservice application on a public cloud, one of the things you need is a system that decides where to run everything, right? On which machines do all these things run? How do I ensure availability? How do I ensure scale, which is the second thing it does, which is kind of manage capacity and utilization and automatically horizontally scale your application as needed so that you have the right amount of resources assigned to your application. Kubernetes also deals with healing and health of those applications, detecting failures, recovering failed components, restarting things that die, and in generally ensuring that that application stays up, right? Which is a really important part of going fast. Like nothing is more embarrassing than launching some important new service and then having the thing go down every time it gets used a lot, right? You need to figure out how to solve availability, and systems like Kubernetes do that for you. There's maybe a few less obvious things. If you have a whole bunch of container-based apps or microservices, one really important thing you need is something like service discovery. You need some way for them to find each other. You need some way to find your peer services. If you think back to that architecture I showed you, that network of services are talking to each other and working together, and you need some way for them to physically find each other, and the orchestration systems do that for you. Any system that's about going fast and delivering quickly has to accommodate constant update to the code. Like you do not build an application over the course of like 2 years and launch it and then wait 2 years to update it again. You're constantly updating it. And so automated rollout of change, doing that in a non-disruptive way, being able to roll back when things go bad, those are fundamental capabilities you have to have both in the runtime systems you're using and in your own processes and tools that you know how to automate the delivery of code and to roll back to previous versions as needed. And maybe the final thing which is important is this idea of secrets and configuration management, being able to extract out the configuration of your application and secrets like credentials and keys and tokens out of the actual source code, so those can be configured into the environment. One of the really exciting things that's happening in the community is the service binding and catalog notions of Cloud Foundry that was just talked about are now being applied more broadly across the container ecosystem. And so in Kubernetes and in other container systems, you can use the same abstraction for service binding, for connecting to external resources, and then inject those credentials as secrets into your application. So there's this really nice path where as a developer, as you use things outside your app, the configuration of those secrets can get passed into your application in a secure way and help you go faster. Now, if this is what the core orchestration systems do to help you run your microservices, the next question you should be asking is, well, how do I run the orchestration system? Because all softwares are cursive at some levels. And that's where I think cloud-hosted capabilities are really critical. Part of the reason I think that public cloud and cloud computing in general is taking over how IT runs is because it allows you to focus your energies more on your core application logic. I mean, if anything, the history of especially enterprise IT is all about refactoring the problem so the common kind of plumbing and infrastructure concerns get done by somebody else so that you can focus on your business problem. And so with container management, we're doing the same thing, which is offering these container management systems as part of our cloud as a service. And so we can automate the cluster management for you, set up a container environment, keep it up to date, update versions. You can design that environment to have the resources that you need. So if you think about your app, you might have some microservices that are, let's say, very CPU intensive. So they need infrastructure underneath that has a lot of CPU cores, but maybe doesn't have a lot of I/O or memory. You have other parts of your application, like the social spider in the example I gave, which is doing all this crawling. That needs a lot of I/O bandwidth, and it needs a lot of memory because it's sucking in a whole bunch of data and doing analytics against it. So you might need resources within your cluster that are high memory machines that can handle those workloads. Part of providing a container system is how do you blend and design that cluster to have the resources you need underneath. Security and isolation is critical in all of these systems, and so we've focused a lot of our energies on, in a container application, how do we provide vulnerability insight so you can understand your software and whether it has vulnerabilities built into it. So we can connect to the kind of global knowledge of the IT industry as new vulnerabilities come out or best practices are understood about security. We can actually go look at all your applications and tell you whether you're exposed to any of those vulnerabilities or have issues within your code. You can leverage all the services that we talked about, or this general notion of being able to connect to external services, and do all of that in the context of an experience that's open and uses standard APIs. And so to me, this is the first kind of building block of being successful with microservices, is having a powerful orchestration platform underneath your applications to build those things out. And containers directly in Kubernetes provides that flexible base. It is a really kind of interesting blend between flexibility of the kinds of workloads you can run and speed and ease of use. Now, there are other ways, of course, that you can build microservices, and we've touched on a couple today. The Cloud Foundry path, I think of as kind of a specialization or a more opinionated version of containers, right? In the Cloud Foundry model, you start with code, not with a container image. You allow the system to take over more of the lifecycle management of the software that your application depends on. You just focus on writing code. And for certain microservices, for certain problems, that's actually the right approach. And that runs on top of these same container systems and leverages all of the capability that I talked about. In other microservices, something like a serverless system, in Bluemix, our serverless system is called OpenWhisk. It's an open source project we created that's part of Apache that we run as a service in Bluemix. And it provides an event-based serverless model. And I think that's really good for microservices that are event-oriented in nature. Like if you took the social spider example where I'm constantly trying to learn about you through your social activity, every time you tweet, every time you post something on Facebook, that's an event that you want to grab and incorporate into the profile. A serverless system is a really good model for doing that because you don't have to kind of worry about how to pull for the data and scale the system. You just say, whenever that gets updated, call me and I'll do my updates. And you can blend all these together in a microservices app. Second key thing is once you have a bunch of microservices, how do you actually connect them together? How do you manage them? And how do you secure them, right? You can build a microservice, but think back to my analogy. The end experience of the restaurant is how all those services came together for the user. And so one big problem in microservices is once you have all these microservices, how do you actually get them to talk to each other, manage them, secure them, and have them operate together? And so what you need is a set of technologies that help you create a mesh of services that work together. And that mesh is responsible for things like giving you visibility into your services, ensuring resiliency and efficiency of execution, managing the flow of traffic and doing versioning, enforcing security, and generally giving you policy control over those services. And one of the big announcements that happened in the last week or so is a new open source project that IBM, Google, and Lyft collaborated on called Istio. And Istio is a technology whose purpose in life is to solve that problem of how do you have an open platform for connecting, managing, and securing a network of microservices. So think of containers as how you build each service and the execution environment they run in, and Istio as the technology that connects them together and lets you manage them, right? And Istio does a bunch of things. I'll give you a super quick flyby. One, it focuses on intelligent routing and load balancing and lets you do things like canary testing. Like, I have a new version of my service. I want 2% of my users to go to the new version so I can sniff out whether that's working well, right? Or I want to do an A/B test. All the users from the Western United States should go to version 2. Everyone from the East Coast goes to version 1. Right? Those are the kinds of experiments you want to run in real systems. Istio gives you the controls to do things like that. Resilience across languages. So if you have a microservices app, one of the problems you have to solve is what happens when the service you depend on goes down. When service A calls service B, calls service C, if one of those things has a problem, how do you prevent that problem from cascading through the system and taking down the whole experience? And so you need things like you need things like circuit breakers and intelligent retry logic and fallback plans. Istio provides the framework to give you those resiliency tools to ensure you can build a highly available, resilient application in the face of failures that you're going to see in real life. Fleet-wide policy enforcement is all about how do we do security, how do we control who can talk to who, which services can talk to each other, how do we do that based on policy that's external to the application, so you can come in and configure how this network of services works together. And then finally, in-depth telemetry and reporting, which is how do I give you visibility into all the microservices, how they're operating, how they're talking to each other, and what the flow of traffic is between them. So the goal of Istio is to give you the tools that you need to take the first building block, which is the runtime environment, connect all the microservices together so you can actually manage them and have them work together to build an overall experience. There's 3 other concepts which I won't go as deeply on that are also really important in microservices. One, APIs. Like, we talked about SOA how many years ago? We've talked about APIs for a long time. APIs are more critical than ever. Like, microservices does not work if you do not have well-defined API boundaries between your services. You probably wind up using an API management system. You use things like Swagger to specify those APIs. A well-defined contract is what will enable your team to be successful in microservices. Second thing that you have to have is a mature DevOps pipeline. Like, the whole idea of going fast implies that you have a fully operational, fleshed out, continuous integration and deployment environment where you can make changes and push them all the way to production in an automated fashion and in a timely way. And there's lots of approaches. This is a representation of something that we have in our platform to let you wire together the tools you might use. But whatever approach you take, you have to have mature DevOps to be successful in microservices. And then the final thing you have to have is operational visibility. You have to have monitoring in place that helps you understand how that network of services is working together. And that really alludes to one of the challenges that we have in microservices. Like, every new thing has its dark side, and we should all be kind of upfront about the trade-offs we're making. And I think the most obvious one in microservices is the complexity trade-off. I'll give you a quick example, and you can go read about this. Gilt Group, which is an online retail flash shopping website, They use microservices. They've documented publicly their journey from a monolithic architecture to microservices. In their original incarnation, they had a monolithic app. It was maybe 12 instances running in a cluster. Their current architecture is 400 microservices. Each one is probably at least 3 instances for resiliency. So operationally, you've gone from 12 things that you're running to 1,200 things that you're running, right? It is harder to run 1,200 things than it is to run 12 things. There's a trade-off that's been made. You're trading off speed and velocity in development in exchange for more operational complexity. And in a lot of cases, that's a good trade-off. If you're changing things a lot, that's a great trade-off. But we should all be aware that that's the trade-off we're making. And therefore, all these systems I talked about, controls in the network with things like Istio, container management systems, operational visibility, you have to have those. Otherwise, you're not going to be successful operating the 1,200 things that you're moving towards as you do microservices. And the final thing, challenge is culture, right? Like, you have to have, I started with microservices about people. If you don't change your culture to adopt the ideas of microservices, the boundary between teams, using APIs as the contract, not doing big coordinated releases of everything, you're not going to really see the benefit. Taking a monolithic app, breaking it up into 1,200 parts, and then deploying it as a big monolith of 1,200, don't waste your time. I mean, you're not going to see any benefit out of it. So your culture has to shift along with the technologies that you're using. And I'll end with a simple statement, which is, why the heck is this all happening right now? Why is microservices kind of becoming a dominant way to build apps? And I think there's 2 factors. One is we're all getting better at DevOps. Not everyone is where they want to be on DevOps, but everyone sees the value of mature DevOps processes and really automating the delivery. And second reason is cloud, right? The infrastructure and API capability of cloud makes running 1,200 things an actually a feasible proposition. And therefore, the trade-off that I just described can happen and be valuable to you because you can take all the resources and the programmatic controls of cloud, connect them with your DevOps process. I think these 2 things are why microservices is becoming feasible in the world that we're in today. And so with that, I'll leave you. I hope that gave you some insight into the idea of microservices. I'll be here for questions after. Thank you.
Perfect. Beautiful. Thank you.